Okay, welcome back to the 5.5 notes. We're continuing on page 3 of the notes. And in this case, we're going to be combining functions together. So if you look at this first line here, f and g are getting together here with addition. So there's two ways of writing this. We're going to be using the one on the right, but it'll start looking at like the other one. So when it says f plus g of x, you're going to write it f of x plus g of x. And you might notice that there's the same input on each. That didn't turn out too well there. Hang on. I used x in both of them. Hopefully you can see that you're plugging in the x for both of them. And there's a plus sign between them. Okay, the next one here, where it's f minus g of x, the only difference is you subtract f of x minus g of x, and so on. So f times g of x, you multiply them, and then f over g of x, you put f of x over g of x. So that's what the definitions of those symbols are. And we're going to start down here with these four functions. I've got f, g, h, and k defined here, and we're going to start plugging things in here, okay? So first of all, I set it up. G minus f of 3 is g of 3 minus f of 3. So now I'm going to plug in, I'm going to start by plugging 3 in here. It'll give 13. And I'll put 3 in this one, and I forget what that gives, but I'll uncover it here in a second. It gives 13 also. If you think 3 squared is 9, 8 times 3 is 24, 9 and 24 is 33, and 33, take away the 20 that's right there, would give 13, and so this one here just turns out to be 0. Okay, k times h of 27, you're going to take k of 27 times h of 27. And when you plug in 27 right here, 2 times 27 minus 3, you're going to get 51. 2 times 27 is 54, and then take away 3. And then on the other side, you're going to be plugging in 27 right there. 3 times 27 is 81, then you square root the 81, you get 9. And all there's left here is to do a little bit of multiplying. 459. Okay, now we're combining k and f. We're doing it with division, so k over f of negative 1 is going to be k of negative 1 over f of negative 1. That's how it's defined to be. And so if you look up here, when you plug in negative 1 down here, 2 times negative 1 minus 3 is going to give negative 5. And when you plug in negative 1 here and do all the work, let's see, negative 1 squared is 1, and then 8 times negative 1 subtracts 8, so that's negative 7, and then finally minus 20. So let's see if I'm right. Yep, 5 over negative 27. You can see I've color-coded it there, so if you want to pause the video and kind of digest that, you can. Okay, the next one is we're going to combine g, h, and k. We're going to take g minus h plus k. We plug in 3 on all of these. So that's what that means. Plug 3 into g. And let's see, if you put a 3 right there, you get 13 on that one. And if you put a 3 in this one, 3 times 3 is 9, but you square root it, you get 3. And then down here, 2 times 3 is 6, take away 3 is going to give 3. So if you do all those, you end up with 13 for your final answer. And I've kind of color-coded it there so you can kind of figure out which is which. Okay, we're going to use g minus f of x. Now, if you look down here, this is a little tricky to understand here. You're going to plug that x in first right here, so when you replace the x with another x, it doesn't change anything. You just get the x plus 10. Another way to think of that, let me uncover the first line here. Hang on. So when I uncover the first line here, you're going to see it says g of x minus f of x. Well, we already have those defined for us at the top here. G of x is simply this part. That's g of x. It says it. G of x equals x plus 10. And f of x is that right there. So you don't really make any changes. You can think of substituting an x in place of the x, but that doesn't make any changes anyways. So anyway, let's go ahead and write down the two functions. The first one in green there is the g of x. The blue part is what I copied from the top of the page for f of x. And if you distribute the negative sign and collect your like terms, I think you get, yeah, that looks right. There's a double negative when you subtract that 20, so 10 minus a negative 20 is where that 30 came from. Okay, g times k of t. So we're replacing the x's with t's, and we're doing it first in this one, and then in this one. And when you replace those x's with t's, then you're supposed to multiply them together. So come on down here, and I'll show you all the math. First, you say g of t and k of t, plugging in t into both of them, looks like that. And now you just multiply those out. And we got one more here, f minus g of x plus 5. Now this one, if I recall, is going to take a lot of work here. So let's see what we get here first of all. Okay, it's f of x plus 5 minus g of x plus 5. So we're going to take that x plus 5, and when we plug it into f, you're going to put it there and there. X plus 5 will replace those. And over here, you're going to put an x plus 5 for that one. So this is what it looks like. Let me uncover it. We're going to replace all the x's in the original functions with x plus 5. And once again, I color-coded it. The x plus 5 being shoved into function f is that kind of bluish green there. And then the pink part is the g of x plus 5. And there's quite a bit of work here to figure out what that is. That's a long, tedious problem, and it'd be one of the more difficult ones to do without making a mistake. So hopefully I haven't made a mistake here. All right, g over f of x is by definition g of x over f of x, and we're not replacing the variable with anything different. It says x there. So we're just going to copy from the top. G of x was at, I believe, x plus 10. And then I copied the other part there. The tricky thing here is that you may not recognize this, but this simplifies further. You get 1 over x minus 2 when you factored and canceled. So that does it for page 3. And when we get to page 4, it's going to be entirely different. You're going to learn a brand new symbol on page 4.